Sorry, but the price of both of these has doubled. Which are you more likely to give up and why? Well, assuming that you don't have your own car and you need to take public transportation to get to school and you need to take it to get to your job, you most likely would be less likely to give up the TTC fare, being more of a necessity and pizza more of a luxury. So we're looking at today, and this relates to that last slide, something called price elasticity of demand, or PED. The law of demand states that a fall in the price of a good raises the quantity demanded. The price elasticity of demand measures how much the quantity demanded responds to a change in price. Demand for a good is said to be elastic if the quantity demanded responds substantially to changes in price. Demand is said to be inelastic if the quantity demanded responds only slightly to changes in the price. So an introduction to price elasticity. This is an activity that we have done in class, where you're asked to drag, I don't think it's not going to happen here, no. We open up a Smart Notebook file on this, and you drag and drop the different activities depending on whether you think it's highly responsive to a change in price. So if price goes up, you buy substantially less. If price goes down, you buy relatively more. Or is it highly unresponsive? The price elasticity of demand, the equation is percentage change in quantity demanded over percentage change in price. And a short form for this is percentage delta quantity demanded over percentage delta price, delta being change in. So percentage change in quantity demanded over a percentage change in price. So if we think of a dinner on a plate, and we've got D over P, or here is the D over P. Maybe if this helps you to remember the formula, so be it. You can also realize that anything to do with any of the different kinds of elasticities will always have something to do with money on the denominator. So it will either be a change in price or a change in income if we're looking at income elasticity of demand. So look at these testers and see if you can figure out which is elastic and which is inelastic. We'll take this up in just a minute. So necessities, would they change a lot to a change in price or not? This would tend to be inelastic, where it would not change a lot because chances are you have bought the necessities you need. Luxuries would be elastic because if the price went up, you could easily stop using them, such as vacations, meals out, fancy watches, jewelry, and so on. And if on the other hand, if price went down, you probably have a pent-up demand for luxuries and would love to buy some more. Goods with close-up substitutes. So if the price went up, you could easily switch to something else. And if the price went down, you would probably switch from the other substitutes to it. So it's elastic. A broadly defined market such as food would be inelastic because it's very difficult to give up all food if the price goes up. But a narrowly defined market such as vanilla ice cream would be elastic because you could easily switch to other flavors or frozen yogurt and so on. Proportion of items spent on an item. So if it's a stick of gum, this would be inelastic because if gum goes up by even if it doubled, you really wouldn't feel it since it's such a small percentage of your income. But if it was a large percentage of your income, then it would tend to be elastic. Time horizons. So if we think of gas prices rising, Do you have time in the short term to switch to a more fuel-efficient car, to maybe move closer to work, to start carpooling and so on? Chances are no. So it tends to be inelastic in the short run because you don't have time to change your lifestyle patterns. But in the long run, yes, you might get rid of the big car, move to a smaller one, move to a hybrid car, move closer to work and so on. So it tends to be more elastic in the long run. And addictiveness, that would tend to be inelastic because it can be difficult to give up. So again, test your understanding here and which would be more elastic in each of the pair of goods. Maybe circle your answer and then we'll take that up in just a minute. So Cadbury's chocolate, if the price went up, you would switch to something else, so it would be more elastic. Orange juice you could give up more easily than water, water being a necessity. Cigarettes are addictive. Candy bars would be probably easier to give up, so elastic. Salt or potato chips, salt is used in so many different recipes and so on. Athletes need it to replenish different things when they exercise as well. Heating oil in a week or in a year, so more elastic in a year because you can adjust your house, you could put in extra insulation, move to a smaller house, all sorts of things. Bread or caviar, well, for most of us it's easier to give up caviar than it is to give up bread. So calculating the price elasticity of demand. So again, there's the formula, percentage change in quantity demanded to a percentage change in price. And here we have a 10% increase in the price of ice cream and a 20% decrease in the amount purchased. So in terms of quantity demanded, we know that we have the 20% decrease, hence the negative sign. And in terms of the price increased by 10%. We divide 20% by 10% and we get -2. But so technically, if we use this formula, PED will always result in a negative value because of the law of demand. As price goes up, quantity demanded goes down. As price goes down, quantity demanded goes up. So they move in opposite directions. But please note, just for this type of elasticity, although the number is negative, the figure is usually reported as a positive number. Since price elasticity of demand is reported as a positive number, the larger the price elasticity implies a greater responsiveness of quantity demanded to price. In other words, the larger the PED, the more price elastic the demand for the good is. Now, we might not always be given the formula in a nice tidy number such as percentage change in quantity demanded and percentage change in price. So we may have to actually refer to the new price, the old price, the new quantity, the old quantity. So to help you remember this formula of Q2 minus Q1 divided by Q1 and P2 minus P1 divided by P1, I ask you to think of what sound does a cow make. Obviously it is moo. So what I like to tell students is imagine that we have a new imaginary animal that makes the sound new. And this being new minus old divided by old. So the N, the O, and the O. So new minus old divided by old. And that really helps to remember how to set up the formula. And once again, the denominator always has to do with money, so in this case price. Or you could think again of dinner on a plate, the difference in quantity demanded over the difference in price. I'm sorry, percentage change in price, my apologies. All right, so let's look at this first example where we had the price of strawberries rising from $4 to $6 a box, and the quantity demanded decreases from 1,000 to 600 boxes a week. And we're asked to calculate the price elasticity of demand. I would start by writing out the formula, in terms of what we need. We don't have the percentage change given to us, but we have P1, P2, Q2, and Q1, so that's the formula we have to use. Then I would make a point of bulleting out what is the original quantity, the new quantity, original price, and new price. So the original quantity was, so it decreases from 1,000 to 600, and then the price changes from $4 to a new price of 6. So let's now use the formula. So PED equals Q2, so it's going to be 600 minus 1,000 over 1,000. And I'm not a fan of a fraction on top of a fraction, so I'm going to write instead divided by. So P2 is 6 minus 4 over 4. So let's do the math. We've got negative 400 over 1,000 divided by 2/4. And so we'll go to simplify. And we've got negative 2/5. And we're going to simplify this into being 1/2. And we're going to multiply by the reciprocal. And so we're left with negative 4 over 5. And just a reminder, when we write the PED, we can ignore the negative sign, and we want to write it as a decimal, not a fraction. So it's 0.8. That's our answer. So you'll find out afterwards if it's less than 1, we're going to call it inelastic, and if it's greater than 1, it will be elastic. So let's look at another one. We've got the price of pizza, $16, and 100 pizzas are sold. When the price falls to $12, 120 pizzas are sold. Again, asked, to calculate the price elasticity of demand. So I'm going to write the formula out first. I'm going to think of the formula new minus old over old. I'm going to realize that the denominator has to do with money. So if the denominator has to do with money, then the numerator must have to do with quantity. So new is going to be Q2 minus the old of Q1. I'm going to divide by Q1. New minus old divided by old. And we have P2 minus P1 divided by P1. New price, new minus old divided by old. Then I'm going to bullet out what everything is, so I don't make a mistake. Now I had to redo the slide before because I had made a mistake, a careless one, and it is so easy to make a careless mistake. So you really want to try to avoid any margin for error. So quantity, we have 100 pizzas are sold initially. A price falls and then 120 pizzas are sold. The original price of pizza is 16 and it falls to $12. Okay, we have everything we need now, so let's go ahead and do this. Q2, so 120 minus 100 over 100, and we're going to divide by P2 is 12 minus 16 over 16. So 120 minus 100 is 20, divided by 100, divided by negative 4 over 16. So let's clean this up. So we would have 1/5. This is 1/4. Multiply by the reciprocal. We're left with negative 4 over 5. 5. And so PED, we're going to get rid of the negative and express it as a decimal. And once again, we have 0.8. All right, now this is almost embarrassing, but you're going to see just a coincidence of the answers. It is completely happenstance. It's just the 3 examples I plucked out, you'll see in a moment. So now we're dealing with a 10% increase in the price of a particular good. Gives rise to an 8% decrease in quantity bought. What is the price elasticity of demand? Well, this one's going to be easier because it's given to us in percentage change already. So PED equals, so the denominator has to do with money or price, so the numerator must have to do with quantity. So percentage change in quantity demanded over percentage change in price. So the percentage change in quantity demanded gave rise to a negative 8%, and the price went up by 10%. We're left again with negative 0.8, and we can get rid of the negative sign and just say that the price elasticity of demand is 0.8. I promise this is the last example where it's going to equal 0.8, and not all elasticities, of course, are going to equal that. So the range in values. We say that demand is price inelastic when the PED is less than 1, but greater than 0. Quantity demanded is relatively unresponsive to changes in price. So what might not change much to a change in price? Well, we know that sort of necessities. If the price goes up, you're not going to buy a lot more. If the price goes down, you're going to still try to buy as much as you can because you need it. So necessities could be things like food, gas for a car, something like insulin, etc. These things would tend to be inelastic. So inelastic demand, where elasticity is less than 1. So we tend to represent that as a fairly steep demand curve. So here, if we did have, let's say, the price decreasing, we would have this being Q1 and this being Q2. You can see that in response to the change in price, the change in quantity demanded is very small. So this is why we tend to depict an inelastic demand curve as being quite steep. Demand is price elastic when PED is greater than 1, but less than infinity. So quantity demanded is relatively responsive to price changes. This we tend to draw as a quite flat curve. Let's have, in this case, the price going up rather than down. We'll have this P1 and this being Q1, and we'll increase the price to here. This is P2, and this is Q2. So once again, in terms of relative changes, we have a relatively small change of price and a proportionately greater change in quantity demanded. So we say that it is elastic demand because it's relatively responsive to a change in price. Now demand is unit elastic when PED equals 1. So a change in quantity demanded is equal to the percentage change in price. The percentage change in quantity demanded is equal to the percentage change in price. So a 5% increase in price leads to a 5% decrease in quantity demanded. Now you will be not asked to describe this curve, but it is what's called a rectangular hyperbola. Comes down, it will never meet the x-axis, and this is the demand curve. That's when it's unit elastic. Now demand is perfectly inelastic when PED equals 0. So there's no change in quantity demanded no matter what happens to price. So this we're going to draw as a straight up and down demand curve. This is our demand curve. And so as price changes, let's say from P1 to P2, we notice that it just stays at Q. There is no change at all to a change in price. Now PED equals 0. Let's say you needed to replicate this scenario. So if we look at PED equals percentage change in quantity demanded over percentage change in price. This percentage change in price, we could give it real numbers and come up with a real percentage change. So I'm going to say that's going to be some value that you could estimate. But the change in quantity demanded, because it doesn't change at all, will be 0. So 0 over some value will equal 0, and so that's why we say the price elasticity of demand is 0. Now demand is perfectly elastic when PED equals infinity. So what happens here is that we're going to draw a straight horizontal curve. Call this the demand curve. Here's our price. When a change in price results in an infinitely large response in quantity demanded, if the price drops below the market price, so if the price is down here, consumers will buy all they can get hold of, an infinite response. If price rises above the market price, quantity demanded will drop to zero. Now we're going to look at this more later with theory of the firm and why that is. But let's look again at the formula. PED equals percentage change in quantity demanded equals percentage change in price. Now if we were to go from one quantity to another quantity, we could find that value. So the percentage change in quantity demanded is some value. But we're seeing that the price is not going to change at all, so it has to be over zero. Now if you put in a value in your calculator and you get closer and closer and closer to zero when you're dividing, you will see that the number gets larger and larger and larger. So this is why they're saying it's infinity. So some value over zero, some mathematicians say infinity, some mathematicians say it's not defined, but for the sake of economics, we refer to the example that it's infinity. So let's look at these. Price elasticity of demand determines whether the demand curve is steep or flat when you're going to draw it. So if you think of these different letters, so we know that this is perfectly elastic. Now look what happens if we add an extra line up here, just for the sake of it. Doesn't that remind you of an E? So that's one way to remember that elastic is the horizontal or a flat curve. This, if it's completely up and down, perfectly vertical, this is perfectly inelastic. And if I put a little dot up here, wouldn't that remind you of an I? And there is the inelastic. Now let's say something is not perfectly elastic, so it's not completely horizontal. If it is more horizontal than steep, we say that it's elastic. If the demand curve is more steep than horizontal, more closer to an I than an E, we're going to call it inelastic. So here are some typical price elasticities of demands for different products. Well, first of all, here are the products. So try to imagine if you think they're going to be elastic or inelastic. And there are the values. So private education is somewhat elastic. So if we raise tuition, we will lose a larger percentage, relative percentage change in quantity demanded. Whereas for something like salt, if we raise the price of salt, we won't really lose much of quantity demanded at all. Total revenue, and we're going to need this concept as we move through the elasticity. But total revenue is not profit. It's the overall money or revenue that a firm takes in, and it equals price times quantity. So on a demand and supply graph, and assuming that we're operating at the equilibrium, this is going to be the price that the good is sold at and the quantity. So in terms of total revenue, so total revenue is going to equal price times quantity, which in math is the same thing as the area of P times Q. So if demand for a good is price elastic, the percentage change in quantity demanded is greater than the percentage change in price. Then if the price is lowered, then the change in quantity demanded will be greater on a percentage basis. So what would we expect total revenue to do? Now that's a lot for me to take in. My mind's going a little bit blank. So let's look at it with the formula. So percentage change in quantity demanded over percentage change in price. Now let's go back and let's see what happened. the percentage change in quantity demanded is greater than the percentage change in price. So if the price is lowered, so we're going to have the price lowered. So before we go any farther, we know that because of the law of demand, if the price decreases, quantity demanded is going to increase. But now I want to see which change is relatively bigger. So if the price is lowered, then the change in quantity demanded will be greater here. So let's give this 2 arrows. Now this is my own method of looking at this. Don't do it on an IB exam unless you're doing it for your own sake. They'll have no idea what you're doing. So then I like to look at this a little bit in the extreme. The chances are it's not going to happen to this extreme basis. It'll happen somewhere much more moderately, but it still will prove the same point. So we've dropped the price by a bit, but we've picked up a whole lot more customers buying our good. What do you think happens to total revenue? Price went down by a little bit, but the quantity bought went up by quite a bit. So then you would expect total revenue to increase. So that's one way of looking at what's going to happen. Do not memorize what's happening because it's not necessary to memorize it. Look at it in terms of what you think is going to happen and reason it through. So let's look at this graphically. We were told that the good is price elastic. We were told that up here. So we're going to draw a relatively flat demand curve. Okay, and we have the price decreasing. Okay, so let's go from P1 to, let's say, P2. And we've gone from Q1 to Q2. This is Q1. So our initial total revenue was P1 and Q1. So that's this. And our new revenue is now all the way over here and all the way over here. So you could also tell by the shaded total revenue boxes that total revenue increased. Conversely, if demand for a good is price inelastic, then a reduction in price is going to lead to a smaller percentage change in quantity demanded. Therefore, total revenue would, well, again, I can't take all that information in at once. So let's look at it with the formula. PED equals percentage change in quantity demanded over percentage change in price. Now, did price go up or down? We have reduction in price, so it went down. Automatically, we know that quantity demanded went up. Okay, so now we're going to see that the price with a reduction in price results in a smaller percentage change in quantity demanded. So in terms of which is relatively smaller, it's the numerator. So I'm going to give a second set of arrows to the denominator. Once again, my method for doing this. If it works for you, that's great. So now I'm going to sit back and say, okay, so we've dropped price by quite a bit, and in dropping price, we've only picked up a little bit of extra customers and a little bit of extra sales. So I would say that total revenue has decreased. Now we can also look at it on the looking at the demand curve graphically. You want to draw the demand curve a little bit away from the y-axis in order to see what's happening. So just from experience, if you draw it too close, you'll look at it and you go, I'm not sure what's happening. So let's take it a fair ways out and draw a steep demand curve for inelastic, closer to the eye. Let's have a reduction in price. So we'll go from P1 to P2. This is our Q1. This is our Q2. So our total revenue before dropping the price is this big box here. After we drop the price, our total revenue, sorry, I'm going to try and get the blue happening. Our total revenue is, no, the blue just does not want to happen. Let's give this one more try. Come across here and then down here. That second box is considerably smaller. These are both, by the way, total revenue boxes, total revenue before and after, and so total revenue has indeed decreased. If a good is unit elastic, so PED equals 1, then a change in price is going to have the same percentage change in quantity demanded. And so what would happen to total revenue? So let's have price go down by arbitrary number, 10, and we have quantity demanded goes up by 10%. So the one offsets the other, and total revenue stays the same. So let's look at this in terms of a business sense. What's going to happen to total revenue if a jeweler were to raise her prices and assuming demand is price elastic? Okay, I can't tell you in an instant. I need to write out the formula. So percentage change in quantity demanded over percentage change in price. Now, did price go up or down? She raised her prices, so we know quantity demanded will go down. Now we have to see which is relatively greater in terms of a change, quantity demanded or price. So if demand is price elastic, demand is going to change by quite a bit more than the change in price. So we'll give this 2. So she raised her price, she lost quite a few customers, so total revenue in this case went down. Don't memorize what's happened here. Be able to reason it through. What will happen to total revenue if a jeweler were to lower her prices? Again, assuming demand is price elastic. Okay, so we're going to have her lower her price. We know she's going to pick up customers because of the law of demand. And demand again is price elastic, so we're going to have quite a change in quantity demanded. So here we have someone who lowered her price by a bit, but she picked up quite a few more customers and sales. So total revenue in this case went up. Suppose flooding destroys a substantial portion of this season's crop. Using appropriate diagrams, explain what is likely to happen to farmers' revenues, assuming the demand for the product is highly inelastic. Okay, so let's take this bit by bit. We've got flooding. And we've got the crop and price of the crop. So let's just look at a regular demand and supply curve just to see what's happening. Here we have PE and QE. All right, so if flooding's destroyed the crop, well, we know that the supply curve is going to shift to the left. And we will have S2. And what happened to price? Price went up and quantity went down. So what we want to appreciate is the fact that price has increased, and we want to focus on the demand curve. We're told that the demand is highly inelastic, which it often is for something like wheat. It tends to be a necessity. If you're having wheat for bread, you buy as much bread as you need for your family. If price goes up, you try to buy the same amount of bread. If price goes down, you're not going to buy a whole lot more because you're using it as necessity. So let's draw an inelastic demand curve. We know that price increased, so let's call this P1, Q1, call this P2, and this is Q2. So the total revenue for the farmer before anything happened, sorry, let me try and get the tangerine color. No, let's try one more time. Well, I'm sorry, it's not working, but okay, the total revenue before is here, and the total revenue afterwards is here. So we can see in this actually rather disastrous situation that the total revenue for the farmer actually went up. Okay, so let's look at something that you could probably relate to. Why are different prices charged for different age groups, for movies, amusement parks, etc.? How is the owner trying to maximize total revenue? Well, are they being nice when you go to Canada's Wonderland and they charge your little brother or sister a lower admission, or a movie and a child gets a lower amount? Let's find out. So let's look at, let's say, Canada's Wonderland. Let's look at PED for youth. Okay, to go to Canada's Wonderland, it's going to take up a fair bit of your income. You don't have a lot of income to spend, so your PED is probably going to be quite elastic. Because if the price goes up, you might really stop going there. So let's look at it with the formula. So percentage change in quantity demanded over percentage change in price. Now, in terms of Canada's Wonderland, do they charge more or less for youth compared to adults? Well, from what I understand, and if it's not Canada's Wonderland, then certainly movies, the price is lower. We know if the price is lower, we're going to pick up more quantity demanded. But if it's elastic, I'm going to put the second arrow on the numerator because we've picked up percentage-wise more than the change in price. So in this case, total revenue will increase. Let's look at PED for adults. Whether it's a movie or Canada's Wonderland, it's not a big proportion of an adult's income, at least generally not the case. So they tend to be inelastic. Let's look at the formula. So who do they charge more to? They charge more for adults. So we'll have the price going up in this case, and we know quantity demanded will go down. But because it's inelastic, the response of the numerator is less than the denominator, so I'm going to put the second arrow on the price. So they can raise price by a fair bit or a chunk and not lose that many customers. So again, total revenue goes up. So these business operators are not being kind and nice by charging youth less money than adults. They're being savvy and trying to maximize or increase their total revenue. So why are business travelers charged more for airplane tickets than vacation travelers? Well, let's look at a business traveler. He or she has got to get to that meeting in New York City. It's just been announced. The price is very high, but it'll be a deal breaker if they're not there. So their PED tends to be inelastic. So again, let's look at the formula. Percentage change in quantity demanded over percentage change in price. They tend to charge more for business travelers, knowing that they're going to get less quantity demanded. But because it's inelastic, the change in price can be greater than the change in quantity demanded, and again, total revenue goes up. Let's look at vacationers. PED tends to be elastic. They can change when they're going to fly. They could take a boat, they could take the car, they could decide not to go on the holiday at all and stay somewhere close by. So they tend to be elastic. Their prices tend to be lower. So if the price goes down, we know quantity demanded goes up. But if it's elastic, they're really going to respond to a change in price. So once again, if they lower the price, their total revenue will go up. So this is why you tend to see this form of price discrimination, which we'll look at later on in microeconomics. But again, it is increasing total revenue. So I'm not going to ask you to memorize this, but just in summary, when a demand is elastic, an increase in price causes a fall in total revenue. A decrease in price causes a rise in total revenue. Now I'll let you read the other two. I would never, ever memorize this. It'd be so easy to mix it up, and doesn't take that long to quickly recreate what's happening, the way we've been doing for the last few examples. And so a final note on a linear demand curve. You may need to use this information. It's a little bit obscure, but nonetheless. So technically, a straight line demand curve is going to have varying elasticities. What's going to happen is smack in the middle. This is going to be what we call unit elastic. Now let's look at what's happening at this upper part change here. So let's look at PED equals percentage change in quantity demanded over percentage change in price. So if I asked you the percentage change in price, from 99 to 100, that's very small. But the percentage change in quantity demanded, if you're going from 1 to 2 or 2 to 1, that's doubling or going by half. So that's like 100%. So that's very large. A large number on top of a small number will be elastic. So as you move along the curve this way, it becomes more and more elastic. Let's look at conversely what's happening down here. If we go from a price of 1 to 2, we're doubling. So that's very large. So the change in price is large. If we're going from a quantity of 99 to 100, that percentage change is small. A small number on top of a large number will be inelastic. So as you move along the curve this way, it becomes more and more inelastic. One way I remember this, so I don't have to recreate all the numbers and everything when I want the answer quickly, is if I think when I'm going down the curve and from left to right, in terms of the alphabet, E comes before I, and so I can quickly remember which is the elastic portion and which is the inelastic portion. Thank you.